So today we'll be talking about a data management concept called streams. So this particular concept will be more applicable in a data management scenario, like if you have a huge database or a data warehouse and you're trying to let's see how we'll go much detail into it, what it is. So we'll try to learn what streams are, what do they do, okay, and how can we use it, in what kind of scenarios or applications will they be helpful. So this is what we'll try to learn. To start with, I'll give you a use case where streams, or what is the need for something called as streams. Okay, so let us think of a situation like, are you all able to see my screen in the first place?
Yes, sir.
Yes.
Yeah.
Okay, great. So think of a situation where you're working for a large organization. Okay, so normally when you're working with smaller organizations, they might have their data stored in a single database. So in that sort of situation, this concept may not be that relevant. But when you're moving on to a higher and higher or larger organizations, so their data will be more diverse, and very huge volumes of data will be present in multiple databases or stored across different platforms. So for a simple example here would be, we are taking for each sort of a function, like they can have a separate database or data warehouse. HR could be in one separate database, or sales could be in one separate database, finance could be in separate, and likewise. So oftentimes and when you have such different data sitting in different data sources, you might want a single place to connect all this data for you to do analysis across all these stuff. There might be some requirements like that. In that case, you want data, you will create one unified data source where the data from all these separate individual data bases will get accumulated into one place. So that is one use case. And when you create that sort of a scenario, your data sources, right, whatever the source databases are there, these will be connected to the database or product systems. Let's say, for example, sales database, this would, you can think that this may be connected to Salesforce or any other tools that are related, that helps you as a company manage your sales, right? So all the data from that product will be directly dumped into this original sales data. Now, and likewise for HR as well. Now, once the data from the product is dumped into these databases, you want this data to be also transferred to the unified database that you created. So to maintain that, whatever the data that is being changing, be it new data that is coming up or old data that is getting deleted, or any updates that happened, all of that needs to be in sync in both the original databases and also the unified database that you have created. And streams is exactly a type of concept that comes here to make sure that data is in sync across all these different databases. We'll see another scenario. Let's say, for example, there may be also a case where when you are creating some sort of when you have some sort of a sensitive data, let's say, and you want to give access to this database, what will happen is you will create two databases. The original database will have the A to Z complete entire data of your organization, whereas in the secondary database, you will create a copy of only subset of certain data or certain tables from the original entire complete database, so that people can work on this subset of data. And when you create that two databases, the original, the complete and the subset data, you want them both to be in sync with each other as well, so that there won't be any issues while doing the analysis on the subset data. So so this is basically the concept that where streams will be helpful to maintain data in a synchronized state and make sure that it is same across all the different database for whatever the reasons that you may have created. So how so what is the thing that streams will do normally is, so let's say you have a data source, a table on the left hand side, the one which I'm pointing out, and you have also created a unified data source on the right hand side. Now the problem, what happens is, for a large databases, for a small organizations, you can surpass this need of having multiple connection or multiple ways to connect to the same data just by creating some views and all, which will be referring to the original database. But when your data is very voluminous, like let's say some millions on millions of records, in that case, having this sort of a view-based approach may not be very appropriate. You have to create tables, because there are a lot of data optimization related techniques that you can apply on tables, but those techniques are not applicable on views and any other objects. So that is why you will be forced, for all those additional benefits, to store the data even in the unified database as a table. But the problem there comes is, if you have to update a table, or if you have to copy a table which is of millions of records on an everyday basis, to make sure that both the tables, the original and the unified table, are in sync with each other, it will take a lot of computation process, and it will take a lot of time as well. It's a very inefficient process, and that is why there is a concept called streams that has been introduced. And what it does is, on a day-to-day basis, it will try to look up the original table and see what all the updates that have happened, changes that have happened, and try to capture only those changes. And some of you may know the term called change data capture. It's called CDC. So whatever the changes that I have done on a table, only those changes will be captured, and those will be stored in an object called stream. Okay, the stream is nothing but, you can think of it as another table that holds the information whatever the changes that have happened on a particular table. So let's say there have been, for time being, some new rows have been added to this source table. So now these new rows have to be transferred to the unified table, right? So instead of copying the entire table once again to the unified table, which will be computational heavy and time taking, so we can just use streams and capture these new records that were only added, and only pass those to the new table wherever the place that we want to add. So that is exactly what streams will help us do. So streams will first identify, once you create a stream object, you have to specify a table that is related to stream object. That means you can link one stream object to a specific table, not beyond that. And that stream object will be policing that particular table to make sure any changes that are happening on that table, it will capture them in that particular stream object. So all the, let's say the 3 records have been added. Those 3 records will be stored in the stream object. And now, instead of referring to the entire original table, you can just refer to the stream object and copy these new records to the new place that you want it to store, so that your original table and your new table are in synchronized with each other with the help of stream object in a much more efficient way. So this is how this is what stream object is used for. The couple of other points just about the stream, just in case. So this particular feature is available in almost all the database management systems, be it SQL Server, MySQL, or Snowflake, whatever it is. But today in this session, we'll focus how we can implement it in Snowflake. And the other thing about, other good thing about stream object is that it will not have a story. Let's say, for example, you have added 3 records here in the original table, and these same 3 records have been stored in the stream object as well, right? But the good thing here for the stream object is that they are not stored as a new value, or they are not duplicated, whatever the new entries are there. They were just referring to the table where they were added. What does that mean is, basically your stream object, even though it is storing records that were changed or added or updated, it doesn't take much of your storage resources. So that means it will be less cost for you. It will just be referring to the values that were there in the original table, but there will be some metadata that is required to capture what changes have happened. So you'll only be using paying your storage cost for storing that metadata itself, but not the actual data itself. So that's a little bit about the streams. Let's try to now move to Snowflake and see how streams work in action. If you have any questions so far, you can let me know before we move to Snowflake. All right. So what we'll try to do today is we'll try to implement streams, the concept that we just discussed. So what we'll do is let's first create the necessary setup. I'll try to be quick. I'm conscious of time. So I've just created some random database so that I can save my stream related objects. So the main essential thing that I will try to do here is, so there is an original table, right? So let me create these two original tables where I'll be doing all the updates and changes. And let me actually, yeah. And there is also a final table. So for which I will I'll try to create a stream object on these original tables, and with that stream object I'll try to sync this final table. Okay, so this is the main goal that I'll try to do. So first let me create these original tables and put some random data in it. So creating my table A. This is table just for sales, like the order, transactions and all. I'm putting some random data in it, and let me quickly so this is my table. It just has some sales transaction related information, what product, how much quantity, and what store, etc. Now let me create my table B, which is the stores table. And add some data into this as well. Just adding 2 stores, one in Chicago and one in London. Let me run this as well. Okay, so now there are 2 stores. Now what I'll do is I'll try to create my final table and try to pull in some rows from these 2 tables. So I'll just try to, here I've joined both the columns, all the columns from both these tables, and created one final table. And I'll try to create some synchronization process between these original base tables and the final table. So to first, what we have to do is, if there is no option of streams, the obvious way we will do is we'll try to do a manual insert statement, right? So we will just insert all the records from both these tables. We'll do a select SQL statement which joins both the base tables, and we'll copy them into the sales table. So this is how we will insert the values. Let's do this first. Okay, and now we can see that all the 5 records have been added into the final table as well. Now let's try to do the same with the help of streams. Okay, what we'll try to do is, first we'll create a stream object. Again, it's a very simple statement syntax. All you have to do is create or replace the stream keyword and the name that you want to give for the stream, and you have to specify on which table you want this stream to act on. So I'm putting one of the base tables, which is the sales table, that which we have created previously, for this stream object to act on. So once I've created it, I can just look at the streams that I've created using this command, and I can see that, hey, there's a particular stream and there's some other properties of this particular stream. And the only thing that you need to remember here is the type of the stream. There are different types of streams that are available, but for now we are just focusing on a type called delta. So what this delta means, it means that whatever the delta, that data that has happened on this table that you have defined, all those all that changes will be captured. So there are different types. We'll get to that later, but let's just focus on the delta type of the stream. So now let me just show you this stream object. As I told earlier, it's nothing but like a temporary table. You can query it just like how you can query a normal table. So I'm just writing a select star from the stream object, and what you can see here is at the moment, it has taken the shape of the base table on which we have created that stream, and we can see all the columns, but at the moment there is no data in it. And the original table, if you can see, there are 5 rows in it. What I'll try to do is, now once the stream is activated on the table, I'll try to add some rows to the original table. Okay, I'll do insert statement and adding 2 rows to it. Once I've done that, now let me check our stream object. Now my stream object, which is supposed to capture all these changes that are happening on this table, it is supposed to now make sure that it has captured these two rows as well, right? So whatever the rows that we have added, it has captured them and stored them in this particular object. Now if you could notice that apart from the 4 or 5 columns that we had in the base table, there are 3 additional columns. This is the columns where we were talking the metadata information is stored for that stream object, and it's slightly important here. So what information it gives us is basically what kind of change using which these records have been added to the base table. So here it says that what action it is. It's an insert action, right? We have inserted these 2 records, and what does it say? The next column is update, is update. So currently it's saying false. What does it mean is you can either insert a new record, or you can also be able to update one of the old records, right? So when you update an old record, the way the SQL goes about it is it will delete the existing record and insert a new record with the updated value. So there is an insert action that happens when you run an update statement as well. So this will help you identify this particular insert action. Is it done directly with the insert statement, or is this insert action, is it done via an update statement? So that is what these 2 columns will help us identify. So currently is update is false. That means this is a direct insert. When it is true, that means this particular insert is happening via a update statement. So yeah, so this is how this metadata information can be used. So now if you would see, instead of in the sales table, I don't have these 2 new records. I have the only original 5 records. Now for me, I can use the stream object to copy the data rather than from the original table. So this will in this particular scenario, it may look like there are only, it may not be much difference, but in the actual real life scenarios, your original table will be of millions of records, and for you to do this statement on the original thing, it will save a lot of your computational resources and time. So now what I've done is I've inserted the same records, same columns in my final table with the help of my stream object rather than the original table. So now if I try to look at my final table, I can see the number of records have increased from 5 to 7 with the 2 new records. And if I try to query my stream object once again, now it will be empty again. So this is another thing to remember about streams, that the data that is stored here will not be there forever. Once you have done the first copy statement or moved it to some other table, the data here will be gone. And that is the main advantage of the stream object as well. It will not hold all the data. It will just hold the data that is changed until it is used somewhere else. So once it is used somewhere else, the data will be removed from the stream object. And it will be waiting for any changes on the further changes on the base table, and whenever those changes are made, it will try to capture it. So that is the let me quickly do one more step. Let me insert 2 other rows in the base table. I think the idea is clear. Yeah, so once I've inserted 2 more records, they are seen in the base table now, 7 to 9, and if I query my stream object, these two records again recorded until they are waited for the further copy, right? Now let me do another copy. Yeah, so now again the stream object will be empty. So this is how you can basically so what we have done is we are capturing all the change data that are happening on a table, and we are using only those change data to update all the other tables or other databases to make sure they're all in sync with each other. Now you can also do this for many other data manipulation languages. So insert is only one of the data manipulation that you can do. There is a couple of other data manipulations as well. You can update the existing data, or you can also delete the data. So let me just take 5 more minutes and finish off these two as well. Now let's say, for example, instead of inserting new records, you are updating records on the same base table. Okay, some values that you are changing, and you want to make sure that these updates are reflected everywhere else. So this is my original table. I have 9 records, and there's a record called banana, and I'll try to change this banana to potato. Okay, and currently my sales stream object is empty, and as soon as I do this update, my original table values have changed from banana to potato, and this change is captured in my stream object. Now for an update statement, unlike earlier, for each insert we will get 1 row, but for each update, as I told earlier, it will have 1 delete statement and 1 insert statement. So it will delete the one with the previous value and insert the one with the new value. And we can see here, are these two actions, the insert and delete, are they directly coming from those statements itself, or are they coming via a update statement? So currently they are holding true. That means these two are coming via a update statement, but they are not direct insert or delete. So again, so now the thing is, now we have captured the updated values. Now the option, the next step is to, how can we transfer this particular update that is captured into our final table, so that the original and the final table are in sync with each other. So there's a bit of code for this. You don't have to worry about this code. You will find it in any documentation of any database management system. Let me just quickly explain. So in Snowflake, there's a term called merge. Typically, this particular keyword is used for situations like this alone. When you have a log of what has been changed in a table, you can use this statement merge to take that log table of all the changes and merge those changes into your destination table. So that is exactly what we are doing here. We are trying to capture the changes that we have recorded in this particular stream object, and we are, based on the ID of the product ID, we are trying to update the new table as well of all the columns. So don't worry about the code and the logic, but this is what we are doing. So whenever you see that this update ID is matching, please update from the stream object into your final table. So once I run this code, my final table should also have been reflected with the new values that the banana to potato change that should be updated. So this is how we can handle the update related statements. Now let's quickly look at one final change, that is the delete statements. So delete is pretty straightforward, unlike update. So let's say I have, this is my final table, this is my 9 rows, and raw table also has 9 rows, and my sales stream currently it's empty because all of them have done. And let me try to remove a record with the product lemon. So I'll just go ahead and delete it, and once I delete it, it will be captured in my stream object, and I can see its direct delete statement, not via an update statement. And now all I have to do is, now since it's deleted in the original table, I have to delete it in the final table as well. So again, we will use the merge statement, but now instead of the update, we will use just the delete command to delete it in the final table. So we will use again merge the destination table with the logs that have been registered in the stream object on the product ID for each, whatever the product ID that has been deleted, please go ahead and delete that record in the final destination table. And once I run this statement, as expected, I can go and see the final table will be in sync with the changes that have been made. So I'll try to stop here, but you may see that we have taken a lot of manual steps, but this is just only to explain how streams object will work in a step-by-step process. If you remember our previous session on Snowflake, we have talked something about tasks which we can schedule on an automated basis without any manual intervention. So those will be running automatically in the backend for us. So people normally combine both the tasks and the streams object, and they create streams on an automated basis. So whenever there is data that appears in the sales stream, it will automatically send data to all the dependent tables and make sure that the entire databases across whatever, how many ever they are in sync with each other without any manual intervention. So basically you can schedule all this stuff that we have done here using tasks, and everything will be kept in synchronization with the original source tables, so that there won't be any data inconsistencies or data errors. So I'll stop here. In the maybe in the upcoming session we'll try to see what other kind of streams are there and how are they different from each other, and if possible we will also try to automate one stream and using task and see how it works. If you have any questions, you can let me know.